All right, here we're going to look at our last section of this unit and in rational functions, and today we're going to be solving them. So we've looked at simplifying, we've looked at graphing, we've added, subtracted, multiplied, divide. Today we're going to deal with and learn this last learning target, and we are going to solve these rational functions. So this is section 7.5. So let's find where we are in our notes. Solving rational equations. And here we're using the word equation instead of expression, because when we're solving we have that equal sign, and that's what turns it into an equation. So the first step is we simplify each side of the equation until it is a single fraction. And we do that by following the previous things that we've learned, either adding or subtracting or multiplying, dividing, getting each side being a single fraction. Then we've got our invisible parentheses. So to get rid of the denominator on the left side, I multiply. So this is kind of our cross multiplication. And then I can simplify. And then to get rid of the denominator on the right side, I multiply both sides by that denominator, and then I simplify. So then I actually go ahead and do my multiplication, and I draw my box and multiply, or I distribute, and then I solve for my variable. So let's look at some examples of how to do this. Okay, so here's our first example. So I'm asked to solve this one. So I've got 3 over x plus 1 equals 9 over 4x plus 5. So step 1, each side is its own fraction, so I can go ahead and cross multiply. So to simplify this side, I multiply by that denominator, and to simplify the right side, I multiply by that denominator. So I end up with 3 times 4x plus 5 equals 9 times x plus 1. Then I can go ahead and distribute those values, subtract 9x from both sides, so I end up with 3x plus 15 equals 9. I want to get that x by itself, so I subtract 15 from both sides and I divide. So I end up with x equals negative 2. Now I just want to double check, because we're dealing with rational equations and expressions, does this work? And all I have to really do is check in the denominators. Will this negative 2 end up giving me a 0 in the denominator? And it won't in either of these, so I know that this one will work. Okay? So here we're going to deal with a word problem next. And I know you guys love word problems. Okay, so an alloy is formed by mixing 2 or more metals. Sterling silver is an alloy composed of 92.5% silver and 7.5%, we're missing a percent sign in here when I printed it off, copper by weight. So I have 15 ounces of 800 grade silver, which is 80% silver and 20% copper by weight. How much pure silver should you mix with the 800 grade to make sterling silver? Okay, so I kind of have a couple of things to figure out, because I want to deal with my percent copper equals the weight of the copper over the total weight. Right? That's how we find percentage of things, is how much do we have over the total. So let's go ahead and get what we have. So I know the percent copper, right, needs to be that 7.5%. So I'm going to write it as 7.5 over 100. Okay, because we always want to get rid of that percent sign. Well, so then the weight of the copper. Well, I know that I've got 20% copper by weight, and I have 15 ounces of it. So that's how much of our 800 grade silver I already have. And so this numerator will tell me how much of it is already copper. So then the denominator, I already have this 15 ounces, and I'm trying to figure out how much do I need to add to get to this final amount. Okay, so that's where all of these things come from. And you'll see I colored and circled them in different colors, and that really helps me. Well, now I see I just have a rational equation with a 1 fraction on each side. So I can go ahead and I cross multiply. So I have my 7.5 times 15 plus x equals 100 times 0.2 times 15. Well, this is just some calculator work. And I can distribute over here on the left side. So I end up with 112.5 plus 7.5x equals 300. Again, just calculator that. So to get x by itself, I subtract that 112.5 from both sides, and then I divide by 7.5. So I end up with 25. So I know I would need to add 25 ounces of pure silver in order to make sterling silver. So the big thing you want to keep in mind when we're looking at this problem is you're going to have another several like that, is these. Where did these numbers come from my equation? Okay, that's the big step right here. So let's look at some not word problems again. All right, so here we go. So solve 5 over x plus 7 over 4 equals negative 9 over x. The first thing I notice is I have 2 fractions here on the left side, so I want to kind of deal with that first. So first I want to figure out, okay, so what is my lowest common denominator? So I see I have both of these denominators have an x, and this middle one has a 4. So if I multiply those together, I end up with 4x. I don't have to multiply all three denominators together because this x is already used in my denominator. Okay, so then I can go ahead and I multiply every single term by that common denominator and cancel things out. So since I'm multiplying this first term by 4x, the x's cancel out, so I'm left with 4 times 5. Here I multiplied by that 4x, the 4's cancel out, so I have 7 times x. And here when I multiply times that 4x, I get rid of my x's, and I come up with a negative 36. Well, so now I actually got rid of all of my fractions, which makes it a little bit easier to handle. Okay, so now I can subtract 20 from both sides, and I can then divide by 7, so I get x equals negative 8. So again, I look and I just double check, does a negative 8 make my denominator 0 anywhere? Which it doesn't, so I know I'm good. So now let's look at this last example. So here we're going to solve 6 over x minus 3 equals 8x squared over x squared minus 9 minus 4x over x plus 3. So the first step I want to do is I want to factor my denominators, right? We're going to factor everything over and over again. We're just going to factor everything. So factor this middle denominator, and that becomes x minus 3 times x plus 3. Then I want to find my lowest common denominator. So I see that my lowest common denominator is actually going to be this x minus 3 times x plus 3. And I know that because each denominator is included in this. I see this x plus 3, that's already included in this, so I don't need to multiply it out again. Okay, so then I multiply every single term in my whole equation by that lowest common denominator. Well, here when I multiply that, I see that my x minus 3's cancel out, so I'm left with 6 times x plus 3. Here in this middle term, both of my denominator pieces cancel out, so I'm left with 8x squared. Here my x plus 3 cancels out, so I'm left with 4x times x minus 3. So then I go ahead and I distribute, and I get everything to one side. So once I've distributed, this is where I'm at. I have 6x plus 18 equals 8x squared minus 4x squared plus 12x. So I've distributed. Well, I see I'm going to end up with a quadratic because I've got some squared terms. So I set everything equal to 0. So I get everything to one side. So I'm dealing with a quadratic where I can go ahead and factor. So first I notice I can factor out a 2 from everything because everything is even. So I factor out that 2. So I'd end up with 2x squared plus 3x minus 9. And then I factor it using my same strategies that I used when factoring any quadratic. So I'm going to end up with 2x minus 3 and x plus 3. So then using my zero product property, I set each thing equal to 0, and I solve. Okay, so I end up with x equals 3 over 2, and I end up with x equals a negative 3. So I go back and I look up in my original problem what would make my denominator 0 at any point. Well, it would either be a positive 3 or a negative 3. Oh, and here I see I have a negative 3. So this we would call an extraneous solution. Remember, we've used that word before. It's something we've come up with, but when we go back and double check, it doesn't actually work. Okay, so this x equals negative 3 would be our extraneous solution. So the only solution that we actually have is this x equals 3/2. Okay, so now we've walked through, and we used some of these same steps, and some of them we tweaked a little bit. So now we've actually gone through all of our learning targets for this unit. So now I really want you to take a minute and evaluate yourself on them. How do you feel about this? Can you classify direct and inverse variation? Can you write inverse variation equations? Can you simplify these rational functions? Can you graph different types of rational functions? Can you add, subtract, multiply, and divide them? Can you solve them? How comfortable do you feel? Because you want to make sure that those are the things that you really feel awesome at before you take your test. But even before then, now it's time to work on that homework and that practice for 7.5. So always let me know when you get stuck, especially on those word problems, because you're going to have some of them as well.